Hello, my name is Rob Reynolds. Welcome to Mat-073. We're in Chapter 2, and we're going to look at our second section, looking at functions in graph, determining the domain and the range of functions, and using the vertical line test to determine whether a function is a function or simply just a relation, a set of ordered pairs. So first of all, looking at the definition of a function, for every x there's only one y. We need to talk about the domain, which are my x's, and the range, which are the y values. So the x's are going to go left to right, and the ranges are bottom to top. And so I'm saying that left to right because I always want the lower number on the left. So over here I'm always going to list the bottom number first, and then I'll move to the top. So if I have exactly one member of the range to which it corresponds to the domain, then we say it's a function. So for every x, there can only be one y. For example, this 8 always goes to a 2. 8 doesn't go to anything else besides a 2. Now 0 goes to 17, but 0 doesn't go to anything besides 17. And this might look a little confusing because the -5 also goes, but the important part is the x values here. X, now if I would have drawn the -5 to the 2, then I'd have a problem because -5 can't go to 17 and to the 2 at the same time. So we're concerned about the x's here. If the x's repeat, then it's not a function. But if there's only exactly one, so -5 always goes to 17. -5 doesn't go to anything else besides 17. 0 also goes to 17, but that's not a problem because the problem exists when 0 goes to two different members of the range. So I would say this is a function. Even though it's confusing right over here, it's the x values that we're concerned with. That only has one y, and that does exist. So I would say yes, it is a function. So looking at this one, for every x is there only one y. Well, Jackson plays football, but then Jackson wrestles, and that's not a function because Jackson can only have exactly one member, and he doesn't. He has two. So I would say no, this is not a function. And it's not a function because for every x, there's not just one y. For Jackson, there's two y's, and that doesn't happen. Now, the rest of this is okay. Max goes to soccer, that's okay. Cade goes to soccer, and that's okay. As long as Max doesn't go to anything else besides soccer, that's a function. As long as Cade doesn't go to anything else besides soccer, that's going to be a function. So a function is a correspondence between a first set called the domain, that's the x values, and a second set called the range, such that each member of the domain, every value of x, there's only exactly one member of the range, which is the y. So for every x, there's only one y. So looking at a set of rectangles. So I've got a bunch of rectangles here, and they each have their own little areas. And those areas are some kind of set of numbers. So maybe the area here is 10, and maybe the area here is 12, because it's a little bit bigger. So for every rectangle, is there only one unique set of numbers? In other words, could this rectangle also have an area of 10 and 12 at the same time? And of course that's impossible. For every x there's only one y, so I would say yep, that is a function. Looking at the next example, I've got a singer and they've got a song title, and so this is nice, but the question is, does each singer only have one song title? If you could come up with a singer who had two different song titles, then it's not a function. And I think I can come up with several artists who have several different songs out there, and so therefore it would not be a function. So Taylor Swift singing, I don't know any Taylor Swift song, so I can't even go there, but she has several songs, so not a function. A relation is a correspondence between a first set called the domain, we got that already, and a second. So a relation is also a set of ordered pairs between domain and range, the x's and y's, but we don't have to worry about a function. So a function is a special relation such that for every x there's only one y. A relation is just a set of ordered pairs, and we just have to make sure that those ordered pairs have y values associated with them. The most famous relation probably is a circle. People always want to call a circle a function. For every x, so maybe this point is 5, 3, but maybe this point is 5, negative 3. Well, that's not a function, but it is a set of ordered pairs, so it's a relation. So when it's a function, you think about your inputs and your outputs. So maybe the value of x is going in, so we read that f at x, and then out comes the y value for the output. So we put in the x and out comes the, so we say f of x is equal to y. So sometimes you see things like f of x is equal to 3x plus 2. That's the same thing as saying y is equal to 3x plus 2. It's just function notation. So f at x is read f at x or f of x. So x is my input, and then the output would be f at 3. The output in this case would be 17. So if I have a function 5x plus 2, I put in a 3 for x. I'll get 5 times 3 plus 2, and I get 17. And that's an ordered pair. So 3 comma 17 is my x comma y ordered pair, and I can plot that point. So we have some functions here. F at negative 2, I'm going to evaluate this 3 times negative 2 squared plus 2 times negative 2. Be careful here. This, if you don't type this in correctly, if you just type in negative 2 squared, you might end up with a negative 4. You've got to put parentheses around that in order to get a positive 4 if you're using a calculator. So 3 times positive 4 is 12. So this is really 12 minus 4, which should be 8. The next example, I'm going to plug in a 4 every time I see a t. So this is read g at 4. So I'm going to go to my g at t function, and every time I see a t, plug in a 4. So I'll write it 6 times 4 plus 9, 24 plus 9, and end up with 33. This last one, every time I see an x, I'm going to plug in an m plus 2. So instead of 8x plus 1, I'm going to plug in this m plus 2 right into this function right here. So I like to replace x with those parentheses and rewrite that first. Then in the parentheses goes whatever you're going to plug in these parentheses. So m plus 2 gets replaced. I'll distribute the 8 for 8m plus 16, and I'll add, combining like terms, 8m plus 17. So 8, 33, and 8m plus 17 is how to evaluate those functions. If you have a function and a graph and you don't know what the function looks like, which I talked about in a previous video, every time you end up with x to the first, it should be a linear function. Every time you see an x squared, it's a parabola. So I know this is a parabola, but let's suppose that you don't know what this parabola looks like. We're going to plug in our values of x and plug in our values of maybe negative 2 to 2. And if that doesn't make sense, then I'll try different values. So again, negative 2 squared is positive 4. If you type that in correctly, be careful on your calculator to use parentheses. 4 minus 1 is 3. Negative 1 squared is 1. 1 minus 1 is 0. This will be a 1. 1 squared is 1 minus 1, which is 0 again. And 2 squared is 4 minus 1 is 3. So I can see I've got some y values that are repeating. If I plot these points, negative 1, 0, 0, negative 1 here, and 2, 3, I can see I've got this nice, round, smooth parabola. This is called the vertex of the parabola here, and this thing will continue, so I'll put arrows in this direction. So I know that anything that's an x squared graphs this parabolic shape. Absolute values, again, maybe you know what that looks like. If it's x to the first, it graphs a line. We just talked about parabolas. You should know the general shape of this. But absolute values start with the letter V for value. It should graph a V. But let's suppose you don't know that. And I know that this 3 says it's going to be moved up 3 units. So I think the V is going to be here. But let's suppose you don't know that this is a V because you've never seen an absolute value function before. Again, I would plug in some points, negative 2, negative 1, 0, 1, and 2. So here comes function. The absolute value of negative 2 is 2. So 2 plus 3 is 5. 1 plus 3 is 4. 3, 4, 5. And you can see 0, 3 is a point. Over 1 up 4 is a point. But so is negative 1, 4. And that's what forms this nice V shape. Later on we're going to be talking about how it got shifted 3 units up. There's a little bit better graph of it. A vertical line test, I talked about a circle not being a function. Well, the vertical line test says if you just draw a vertical line and it crosses more than once, then it's not a function. So you can tell very quickly whether something's a function or not by the vertical line test. So every time you see a parabola, I think it is a function because there's a vertical line. There's no way to draw a vertical line and make it cross more than once. So that would be a good function. This would not be a function because it's crossing 3 times. This looks like a function because every time I draw a vertical line, it only crosses once, which fits my definition of a function. For every x, there's only one y, and that one y means it only crosses once. This is not a function. I can see it crosses more than once. The first graph and the third graph are called relations. Actually, this is also a relation, but this is a special relation, which we call a function. So all functions are relations, but not all relations are functions. A function is a special relation. So the following graph represents an individual and their target heart rate. And it's going to ask maybe, what's the target heart rate for a 64-year-old? So we'll find 46. We'll find 46 on here, go on up and then look at his target heart rate and say, oh, well, that answer right there, let's see, this is 50, 10, this is 110, 120, 130, 140, so this must be right around 130 is the answer. So if they ask for what is the target heart rate for a 70-year-old, I'm going to do the same thing. I'll try to locate 70, and I'll come up here to the graph. Well, it looks like it's just a little bit above this line, and that line is 110, so I would guess something, just a little bit, maybe 111 or 100, how about 112? Do you think this point is just a little bit above that line? 112. That's a good guess. The author agrees. Great. That concludes section 2.2. If you have questions, feel free to email me.